of waves?
Yes, there are two types of waves. They are called transverse waves and longitudinal waves. They are described based on the direction of vibration of the particles in the medium in relation to the direction of the whole wave.
Wait a moment there. What do you mean by medium?
Medium is the material through which waves pass. This could be solid, liquid, or gas particles. Unlike other waves, light waves don't need any medium. They can pass through a vacuum, which is a space without matter. Let me illustrate this with a drawing. If this is the wave, this is a wave proceeding this way. The particles do not vibrate in this direction. They simply vibrate up and down, like this. As I said earlier on, energy is transferred from one particle to the next.
Would you mind naming the parts of that wave, please, Uncle?
No problem. This part is called the crest. The crest is simply the top. The opposite of the crest is called the trough. The trough is simply a basin. The distance between successive crests is called the wavelength.
What do you mean by successive crests or troughs?
Successive means following each other. Lastly, we have amplitude.
What is amplitude?
Amplitude is the distance between the rest position and the crest, or the trough.
So then it means that the size of the amplitude is proportional to the amount of energy the wave carries?
Yes, I guess the size of the pulse represents the amplitude of the wave.
You are both right. The relative sizes of the amplitudes would tell you how much energy the waves carry.
What are some examples of transverse waves?
Okay, I'm coming there. Some of the examples of transverse waves include water waves, electromagnetic waves, and waves made by shaking a Slinky spring like this.
What are electromagnetic waves?
Electromagnetic waves are simply light waves.
So it means that sound waves are not transverse waves?
No, they are not. Sound waves are called longitudinal waves. In longitudinal waves, the particles in the medium vibrate to and fro in the direction of the wave. Let me illustrate this with a diagram. These lines represent particles in a medium, which could be a solid, a liquid, or gas particles. If the wave is proceeding this way, the particles do not move to the other end. They simply pass on the energy to the next particles until they reach the destination, which could be your eardrum.
Is it possible to demonstrate sound waves using the Slinky spring?
Yes, I can. I'm coming there. If I shake this spring like this, I'm generating waves similar to sound waves. What do you observe?
When you shake the spring, I see parts pushed together, traveling to the other end and back.
Good. You see that waves can be reflected. This property is common to all waves. The parts where the spring is pushed together are called compressions or positions of high pressure. The alternate positions where the spring is pulled apart are called positions of low pressure or rarefactions. Now tell me, what determines the number of crests produced in a given time?
I think it's the rate at which one shakes the spring.
Meaning?
The faster one shakes the spring, the higher the number of crests produced in a given time.
You are right, Mary. The number of crests produced in a given time is called the wave frequency. But wave frequency is not restricted to the number of crests produced in a given time. It can also be the number of troughs or complete waves produced in a given time.
What is the unit for frequency?
The unit for frequency is the hertz, or Hz for short. The hertz specifically refers to the number of complete waves, troughs or crests produced in a second.
Well, Uncle Joe, this was an interesting discussion, but I have to go now. Goodbye.
Bye.
I also have to go now. Thanks, Uncle Joe. Now I know who to consult when I don't understand something in the physical science class. Bye.
Bye.
Now for the SMS competition question. To SMS, you must enter the keyword for the competition and then send the option A, B, or C to the number 8555. The keyword for this program is water, and it is spelled W-A-T-E-R. One SMS costs $3. Don't worry, it's as easy as 1, 2, 3. Here is the question. The material through which waves pass is called A, a gas particle, B, a medium, or C, a crest. SMS your answer to 8555. The number again is 8555. All correct answers will be entered into a lucky draw. The winner will be announced within 3 days, and if you are the lucky winner, I will contact you to collect the prize at the nearest NAMCOL center.
Get on the